Hello, today's lesson is 7.2, solving equations using addition or subtraction. The essential question is, how can we use addition or subtraction to solve an equation? And you're noticing the red star, and the first sentence I want you to write down in your notes is, a solution of an equation is a value that makes the equation true. So there's three examples for us to look at. So if you notice that 2 plus 3 equals 5, then if I go ahead and write 5 in this box, I can say the solution to the equation is 5, because when I put 5 in the box, it makes the equation true. And then you can see for the second example, 2 plus 3 would equal 5. So the unknown value that I'm filling in is 3. So the solution to the equation is 3. And then the last one has 2 plus 3 has to be equal to some unknown number plus 1. And if this side is equal to 5, an equation says whatever's on the left side is equal to whatever's on the right side. This side has to equal 5, so I know 4 is the unknown number. The solution to the equation is 4. So for every one of these, I put in the number that makes the equation true. Now, if I decided to put in something silly that didn't make the equation true, like 6, right? I could say that 6 is not a solution, because when I plug 6 in for that box, the equation is not true. So you have to come up with a number that makes the equation true for it to be a solution. And later in your math career, you'll see that some equations can have more than one solution, but we'll just be working with problems that only have one solution. I'm going to put that 4 back. Okay. So now, if you're solving equations, it's useful to visualize the equation sort of as a balance scale, right? And the variable could be a mystery bag, and it's filled with gold or money. And then when you put weights on the opposite side, right, like as I start to put a weight, right now, if I put 2, now obviously the scale is not actually moving up and down like it would. If I put 2 units onto the scale and it's balanced, then the unknown number x equals 2. If I put a third one on there and it stays balanced, then the x would be equal to 3. So we can look at the variable as being on one side of the equation, and the number that it's equal to is balanced on the other side. So this looks like an equation that says x is equal to 3. Now, with every equation, right, that stays balanced, the idea is I could take one of these and I can put it on the left side and put one on the right side, and it will stay balanced as long as whatever I do to one side of the equation, I do to the other. So I'm going to go ahead and take that back and make that match our equation, x equals 3. So the value that makes this equation true is putting in 3 for the x. All right, so let's look at how do we find the value of a mystery bag. Well, I'm telling you that one of the words that we use in solving equations is called to isolate. So if I get the mystery bag all by itself, then the number that's on the other side of the scale will represent the weight of the bag. So what I want to do is I want to write down the equation that I see. And so I see an x, and then I see these 2 units. So my equation is x plus 2 is equal to 1, 2, 3, 4, 5. Right? So now you can see this sort of matched one of those first equations that I was showing you. The unknown number would be 3, right? So what I want to do is I want to take off one of the weights from the left side, and I take off a weight from the right side. I take another weight off of the left side and another one off of the right side. So now you can see indeed x does equal 3. And I show that with the math below by doing this. See where the balance, this is the fulcrum actually, if you want to know the fulcrum of a balance. I represent it right below my equal sign. This is what I do. I usually just put a line that goes straight down. So this is representing my balance and my scale. And then what I did was I took 2 of those weights off the left side, and I took 2 weights off the right side. And all I'm left with on this side, if I look at the fact that I had a positive 2 plus a negative 2, that's actually called a zero pair, and they cancel out. So all I'm left with on this side is an x. Oops, I just wanted to make that the same color. I have x, and 5 minus 2 equals 3. So my solution is x equals 3. And I wanted to write that this is called a zero pair because it's a positive and a negative number. When you add a positive 2 and a negative 2 together, it's like Shazam, they cancel each other out, and it's called a zero pair. All right, let's look at another example. So this time we've got an equation to write. So if you look at the balance scale on the left-hand side, you see x plus 4 is equal to, it looks like this is two groups of 5, so x plus 4 is equal to 10. So what I want to do is I want the x all by itself. I'm trying to isolate it so that I know what x equals. So I'm going to drag 4 of those weights off, and I drag 4 weights off of this side. So as long as I drag the same number of weights off of both sides, my balance scale stays equal. And then I'm going to show you what I did was I subtracted 4 from the left side. I subtracted 4 from the right side. Oops, I almost forgot. I do like to draw my balance scale in the middle so I can make sure that I'm whatever I'm doing on the left-hand side, I'm also doing on the right-hand side. And remember that when I subtract a negative 4 from a positive 4, a positive and a negative cancel each other out. Those go away. All I have left on my left-hand side is x equals, and then I do 10 minus 4, and I get 6. So my solution to the equation, my solution and the mystery bag is equal to 6. All right, let's look at one more example. Okay, so now you're going to notice that the variable is on the right-hand side, right? And that's okay. It's still showing me that the left-hand side is equal to the right-hand side. If I count, I have 5 plus 4 is 9, plus 2 more is 11. So I've got 11 on the left side, and there's my fulcrum is equal to, now I've got 1, 2, 3, 4, 5 plus x. And I'm just writing the equation in the order that I see it. There's no need to change it around. The variable doesn't always have to be on the left-hand side. And so I'm going to draw my balance scale. I want to get the x by itself so that I know what it weighs. So I'm going to go ahead and remove, right, those 5 weights that are on the right-hand side. And if I take off 5 weights from the right-hand side, I also need to take 5 weights off of the left-hand side, because I want to keep my scale balanced like it was when I started. So I subtracted, grab that and make that red. I took away 5. I took away 5 here. Now there's not a plus sign in front of here, but you know whenever you have a number, if there's no minus sign in front of it, it's a positive number. So again, this is going to be a zero pair, and that cancels out. All I have left on the right side is x, and over here I have 11 minus 5 is 6. And let's check it out. I do have 6 weights left. So my solution is 6 equals x. So again, this was a zero pair. If I take a plus 5 and a minus 5, it equals 0. Okay, so now the property that we've been using is called the subtraction property of equality. Let me move this down so you can see. It says that when we subtract the same value from both sides of an equation, the two sides remain equal. That's what we just did, right? So notice on this scale, I've got 6, right? This kind of looks like it kind of looks like 4 plus 2. And over here, I have 3 plus 3, right? So 6 equals 6. And the subtraction property says if you take 1 from the right side of the equation, you have to take 1 from the left. Or if I take 2 away from the left side, I have to take 2 away from the right side. Whatever I do to one side of the equation, I have to do to the other. And now you're going to notice the next red star in the box, which says inverse operations undo each other. Addition and subtraction are inverse operations. So these were positive values, right? So when I go back to what the scale first looked like, there was 6. So these are being added, right? These are all positive numbers. So this basically says 6 equals 6. And when I was taking the weights away, I was subtracting and I was undoing addition. That's the idea of what we're doing when we use inverse operations. We're undoing the math. Okay, so here's the steps for solving equations. So if you have my notes, they're already written in. If you don't have my notes, then go ahead and pause the video and write these down. The first one is that you want to isolate the variable by using the inverse operation, right? That's where you add or subtract. The second one says keep the equation balanced by using the properties of equality. So sometimes you only have to use one property of equality. Sometimes you use more as the equations get more complicated. And the last thing is you're going to use substitution to check your work. And I'm going to show you what I mean by that. So here's an equation that says p plus 5 equals 8. So I'm going to go ahead and draw the balance. This is like where the fulcrum is for my balance scale. And I look at the side with the variable, right? So I'm always trying to isolate the variable, which means I want to get the variable by itself because I need to know what p by itself equals. So because there's addition here, I want to do the opposite. And so picture taking off 5 weights. So I'm going to subtract 5 from the left side, and I'm going to subtract 5 from the right side. And then I draw a line underneath, right? Because when we do our arithmetic, we're adding and subtracting vertically. And so this is a zero pair that cancels out. It leaves me with p equals 8 minus 5 is 3. Well, you guys probably already figured out that 3 was the number that you needed to add to 5 to get 8. But what I'm trying to show you is a process. And now the next thing I'm going to show you, again, seems kind of silly, but I want you to know that this is the check that you need to do to use substitution to check your work. Okay, so here's what I do. I write the original equation. Always go back to the original equation, and I'm putting the variable in parentheses because I am going to substitute in the value that we found. And what we found was p is equal to 3. So I go ahead and plug in 3 for p. This is the substituting part. And then I write the rest of the equation just like it is. Now I have to do the math to check my work. Now, you know, this one, again, it seems ridiculously easy, but this is what I'm asking you to do. 3 plus 5 equals 8. So I'm proving that the left side of the equation equals 8 and the right side of the equation equals 8. So I know I have the right solution. Now I want to show you the whole reason that you're doing this check is to catch mistakes. And so let's say I made a mistake, and let's say I thought p equaled 4. So what if I got this as my answer? Then when I plug it in and I do my check, I would have this. 4 plus 5 equals 8. And then when I do the math and I add 4 plus 5, I get 9. And my equation says 9 equals 8. Now, here's what I've noticed a lot of people do in my years of teaching this. They look at it and they say 9 does not equal 8. So I must have done something wrong. And so they end up crossing off this 9 and they say, well, I really know what I'm supposed to do is I'm supposed to have 8 equals 8 at the end. But what they don't think about is because they got p equals 4, which is the wrong solution, this, when you get to something that says 9 equals 8, that is supposed to tell you that you made a mistake in your solution. So you would go back and you would check your math again. Now, there's not a lot of math to check here, right, because it's a pretty basic equation. But if you do the check and you get something that doesn't make sense, that means you go back and you check your work. It doesn't mean that you change it to make it so that it's what you think I'm looking for. All right, so I'm going to go ahead and erase that. That's what the check looks like. Okay, so this is a slide just meant to show you. So remember in chapter 3 when we were evaluating expressions, when you evaluate, you also, if I give you the value of a variable, like this one that says, tell me what 24 plus C is when C equals 9, you plugged in 9 for C and then you did the math. So this is similar to checking your answer after you solve an equation. So this isn't new for you, it's just a little bit new in that you're looking at a whole equation instead of just an expression. Okay, so here's the preface. The purpose of the next several lessons is not just to see if you can find the value of the variable, it's to introduce you to the structure that exists when solving equations. You will need to pay attention to the process for solving, as well as checking the solution to an equation. How you replicate that structure is what you will be graded on. So I want you to pause the video for a moment, look at the work that student number 1 did, look at the work that student number 2 did, and I want you to notice the difference between student 1 and student 2. I pointed out the substitution part, and so you can see that student 1 got the solution correct, x does equal 3. They got partial points. They didn't get full credit because they didn't go ahead and do the check and write the original equation, substitute in the value that they got, and prove that the left side of the equation is equal to the right side. Okay, so I'm asking you to write in what you think in your own words these 3 vocabulary words mean. Go ahead and pause the video and try it, and I'll just write in my own words. Yours doesn't have to match entirely, but I'm going to say that you get the variable by itself. Inverse operation, they are opposite operations. And I would say that you undo math, right? So I'm undoing addition or subtraction. And for substitution, this is how I like to look at it. You plug in a value for the variable, right? You could use the fancy math word substitute. I was trying to put it into my own words. I'm literally plugging in the value that I found. Okay, so here we go. This is the first OYO. I want you to pause the video and try these. I'm going to start by putting a balance scale on the equal sign and a balance scale over here. So I always look at the side with the variable, right? Because that's the math that I need to undo. Picture this is the mystery bag and there are some weights that have been added and I need to remove the weights. So I'm going to subtract 6 from both sides and I draw a line underneath and I do the math. 9 minus 6 is 3. And over on the right side, the 0 pair, right? The 0 pair cancels out. That leaves me with y. So I get 3 equals y. I'm going to put a box around that. That is my solution. Now I'm going to check my work by writing the original equation. I write 9 equals. I'm putting the y in parentheses because I know I'm going to be substituting in a 3 for y. So I write 9 equals 3 plus 6. Now I'm going to do the math over here. 3 plus 6 equals 9. So I have 9 equals 9. Check. I got the right solution. All right, the left side, we've got some fractions going on. So I have my balance scale. Picture the mystery bag, and there have been some weights added. This weight happens to be a fraction, but that's okay. It's the same idea. I'm going to subtract 3/4, and I'm going to subtract 3/4 from this side. So now these will cancel out, leaving me with G equals. Now over here I've got some fractions, right? And I've got a mixed number and I'm trying to subtract a fraction from it. So it makes sense to do the math, multiply 4 times 1 and add in the extra 1 to remember that 5/4 is the improper fraction that is equivalent to 1 1/4. So now I've got 5/4 minus 3/4 equals 2/4. Well, wait a minute, that is a fraction that needs to be simplified. So I'm going to divide by 2/2, the common factor, and I end up with 1/2. So my solution is G equals 1/2. Put a box around that, and now I'm going to do the check. The check is the original equation, always. I'm going to put the G in parentheses, plus 3/4 equals 1 1/4. Now I'm going to plug in 1/2. Ooh, this is that's kind of hard. So now here's what I need to do. Over here on the side, I'm going to add 1/2 plus 3/4. You can't just tell me that you know it equals 1 1/4 without proving it mathematically. So I'm going to write the 1/2, and I'm going to write the 3/4. And I know what I need to do now to add them is I have to make common denominators, and then between the 2 and the 4, the least common denominator is 4. This is already in fourths, so I'm going to multiply the 1/2 times 2/2, and I get 2/4. And now I'm going to add the 3/4 to it. I get 5/4. And now I know that 4 goes into 5 one time with 1 left over. So this is equal to 1 1/4. So when I do the math here, I get 1 1/4 is equal to 1 1/4. Check. So don't be afraid of fractions. Don't be afraid of decimals. It's going to be the same process. Okay, next, how about if we have an equation that has subtraction? Now, we could use different colored weights to represent negatives, but right now we just got a -2 on the left-hand side. So when I write the equation, I'm going to write x minus 2 equals 2, 4. I've got 7 weights on the left side. So what I want to do is draw my balance scale, and now I'm going to think about, oh, how do I get the x all by itself if I'm trying to take 2 away from it? Now remember those 0 pairs that I told you about? What if we add a positive and another positive? So now I'm adding 2, and I know that when I have a +2 and a -2, those make a 0 pair. So effectively, I've gotten rid of the -2 by adding in 2 weights. Now wait a minute, whatever I do to the left side, I have to do to the right side. So I want to make sure that I add 2 weights over here. So let's go ahead and do the math, right? I'm going to add 2 to the left side, add 2 to the right side. This is a 0 pair that cancels out. I get x equals 7 plus 2 is 9. Let's make sure I have 9 here. 2, 4, 6, and 3 is 9. Okay, so now all I need to do is do my check, right? I always want to do a check, so I'm going to go back to this original equation and write x minus 2 equals 7. Oops, let's go ahead and write that this is my check. I plug in 9 for the x, so I have 9 minus 2 equals 7. I could do the math over here. Yes, I get 7. 9 minus 2, 7 equals 7. Check. So if you have an equation that has subtraction, when you undo it, you use addition to undo it. Okay, so we can use the addition property of equality. That's what we just used. That says when you add the same value to both sides, the two sides remain equal. So if I add, oops, let's take that away. If I add 1, 2, 3 to this side, I add 1, 2, 3 to this side. So I'm always adding the same amount to both sides to keep the equation balanced. Okay, so now let's try another OYO. Go ahead and pause the video. I always start with the balance scale. I look at the side with a variable. I need to undo a -8. The opposite of subtracting 8, I know, is adding 8. So I'm going to, but I'm going to be careful because there is a decimal. So I'm going to add 8.0, line up the decimals. Remember when we add, we line up the decimals. This is a 0 pair that cancels out. I get n equals 9.5. Now I do my check. Start with my original equation, n minus 8 equals 1.5. I'm going to plug in 9.5 minus 8 equals 1.5. Now, most of you are looking at this going, wait a minute, that's true right now. But what you have to do is you have to do all of the math. You have to simplify the left-hand side to prove that it's equal, right? I'm not looking at this as a whole sentence anymore. I'm looking at it as the left side must be equal to the right side. So now I'm going to show the math that I need to do. I have to actually do the subtraction. There we go. And when I do the math, I get 1.5 is equal to 1.5. Check. All right, here's another fraction. I draw my balance scale. The opposite of subtracting 1/6 is adding 1/6. So I add 1/6 to both sides of the equation. 3/6 plus 1/6. Remember, if the denominators are the same, you just add the numerators. I get 4/6 equals the 0 pair, cancel out, y. All right, I want to simplify the 4/6 by dividing by 2 over 2. Remember, you always simplify fractions if you can. So I get 2/3 is equal to y. You could put the y first, but you don't really need to. I want you to get used to seeing it over on the right-hand side. That's okay. Now I'm going to do my check. And I go back to the original equation, which says 3/6 is equal to y minus 1/6. And then I rewrite it and I plug in the 2/3 minus 1/6. And now I need to do the math because I have 2/3 minus 1/6. Oops, let's make that, the minus was a little bit small. Put in the 1/6 and put a minus there. That looks better. Okay, again, I need common denominators. The common denominator between 3 and 6 is 6. I don't need to change the bottom fraction, just the top. So when I multiply by my giant 1, I get 4/6. So now I have 4/6 minus 1/6 is 3/6. So when I do the math over here, I get 3/6. So I'm running out of room. 3/6 equals 3/6. Check. Okay, so this is just a little bit of true false, right? You can read through these and see what you think. A says in an equation you can use any letter as a variable. Right, for this one I say thumbs up for A. Just be careful. If you use an S, it kind of looks like a sloppy 5. So there are some variables that are better than others, and maybe S isn't the best one to use. B says the goal in solving an equation is to get the variable by itself. That is true. That is a thumbs up. C says in the solution, the variable must always be on the left side of the equal sign. Well, you know already, that is thumbs down. That is not true. If you add a number to one side, you should subtract it from the other. Huh? That just sounds weird, right? That's not going to keep the scale balanced. That would definitely be a thumbs down. Okay, so now I want to, before we go on to some other types of problems, this is going to be very much like the homework and the lesson that you learned in 7.1. I want you to, if you don't know these vocabulary words that mean addition, subtraction, and equals, you might want to write some of these down in your graphing notebook. But these are the words that you'll see that tell you in a word problem if you should be adding or subtracting, right? And then don't forget, ding, ding, ding. Okay, so remember the turnaround words. So this is my turnaround, right? If you say more than, it turns around the order. If you say fewer than, less than, subtracted from. Those are the 3 turnaround words for addition, for subtraction, and then for addition, it would just be more than. So in other words, if I did this, 4 more than X, that means you're supposed to start with the X and add 4 to it, right? 4 less than X means you start with the X and you subtract 4 from it. Same thing with subtracted from. If you have 4 subtracted from X, that means you're beginning with the X and you're subtracting 4 from it. Now remember, there's the commutative property of addition, so really you won't get into too much trouble because 4 plus x is the same as x plus 4, but that is not true with subtraction. So you really have to pay attention to those turnaround words for subtraction. Okay, so write the word sentence as an equation and then solve it. So I'm going to use the process that I taught you where I want you to circle the numbers and the variable and then underline the math words. So I'm circling the 13, the number W, and the 15. I'm going to underline subtracted from and is. This is a minus sign. So it says 13 subtracted from. Okay, there's my ding, ding, ding. There's my turnaround word. So instead of 13 minus W, it's going to be W minus 13 equals 15. Okay, now I need to solve it. I put my balance scale. I look at the side with the variable. I want to get the variable by itself. The opposite of subtracting 13 is adding 13. So I add 13 to both sides. The zero pair cancels out. I get W equals 28. So for this one, I was going to skip the check and just show you how to solve it. And then B, I'm going to circle the 9, the number N, and the number 7. I'm underlining is the difference of, oops, sorry, those are two separate. Underline is, there's the equal sign, the difference of is a subtraction, but it doesn't change the order, it's not a turnaround. So I translate 9 equals the difference of, that means I'm subtracting in this order, N minus 7. Put my balance scale. The opposite of subtracting 7 is adding 7. I'm going to add 7 to both sides. Zero pair cancels out. I get 16 equals N. Okay, now I have this is it, the last OYO. You're going to try these two on your own and then check your answers, but I need to move this over so that you can actually see. Okay, I'll have to do the first one and then move over the right-hand side. Okay, number 5, a number increased by 3 is, so I'm going to circle a number X. I'm circling the 3, I'm circling the 5, I'm underlining is, that's the equal sign, increased by, kind of sounds like a turnaround word, but it's not. That just means you're adding. So a number X increased by 3 equals 5. Draw my balance scale. I'm going to subtract 3 from both sides. I'm left with X equals 2. And now I am going to do my checks. And I get X plus 3 equals 5. This seems really silly because it's so easy, but I just want you to see that I'm actually doing the math on the left-hand side. Oops. 2 plus 3 is 5. So I get 5 equals 5. Check. All right, let me move this over so that you can see. So this one is 3.5. Move this. 3.5. Circle that. Circle 2.2 and a number M equals, well, that seems obvious. Less than, ding, 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 there is my turnaround word, right? I like to draw my turnaround picture so I can remember that it's going to change the order. So I translate 3.5 equals, instead of 2.2 minus M, it's M minus 2.2. And then I draw my balance scale. The opposite of subtracting is adding, so I add 2.2 to both sides of my equation. I get 5.7 equals M. This is a zero pair that canceled out. And now I'm going to do my check. Let me go ahead and put a box around my solution. Okay, my check is 3.5 equals M minus 2.2. And I plug in my 5.7. So I have 3.5 equals 5.7 minus 2.2. Now I'm going to do the math over here. 5.7, 2.2 minus, I don't have to regroup, I get 3.5. 3.5 on the left is definitely equal to 3.5 on the right. Check. Okay, that is lesson 7.2. Good luck.